Okay, thanks, Emma.
Absolutely. Thank you, Catherine. Thank you so much for letting me be a part of this event, this Sheffield Tree Week. It's a real privilege. Let me just upload my presentation. There we go. Should all be able to see the PowerPoint presentation now. And yeah, thank you so much for having me. It's great to see so many people logged on today. And as Catherine said, soil can often be a very underappreciated resource. And it's so important for trees. And I'm going to go over why that is. And what we can do potentially to alter the soil to make it more desirable for trees and for root growth. And as Catherine said, we'll have plenty of time at the end for questions. I'm going to talk for maybe 40 minutes maximum, and then we'll have some time for questions afterwards if anyone has anything specific they would like me to go over. So let me start by introducing myself. I am Emma Schaffert, and I have been working in the arboricultural industry, which is anything to do with managing trees, for over 10 years now. I originally trained in horticulture, and I worked in nursery plantmanship. So I worked with producing specifically trees in a nursery environment and maintaining them before they were sold on to customers. And now I work as a research technician, specializing in projects to do with soils and urban planted trees specifically. I've worked a bit with branch strength and also with biochar, which I'll go over a little bit later in the presentation. But as Catherine said, I'm originally from the UK. I was based in Reading at the research laboratory there, and now I've transferred about a year and a half ago to Charlotte, North Carolina. So I've slightly started to pick up a bit of a twang, but hopefully it won't impede my presentation skills today. The company that I work for is called Bartlett Tree Experts. As I mentioned, I work in their research laboratory in Charlotte in North Carolina. They have several around the world, which is where I transferred from in the UK also. They were founded in 1907 on the basis that they were going to be a scientifically based tree and shrub care company. So every practice that we do as a company, we tend to trial previous to using it. So anything from soil care to pest and disease management to pruning techniques and so on. And all of that information we make available to the public and to other tree care companies and other companies in the green industry. So we're really, one of our biggest morals is to try and promote healthy whole tree management rather than just cutting trees and taking trees down. We're quite into promoting the health of trees and the benefits of trees. So let's start with the basics. What exactly is a soil? And soils are typically made up of 4 different components. The first is the mineral component, and that I'll discuss more in depth in a second, but that tends to make up about 45% of an ideal soil. So this pie chart is showing what an ideal soil would look like. 50% should be the pore space or the porosity of the soil. And then that ideally would be equally split between air and water in those pores. And then we have around 5% organic matter or humus, which essentially is any kind of recycled biological matter or biomass that is recycled back into soil. So things like leaf litter, branches that break down, animal waste, anything that kind of contributes to that organic matter in the soil. And that's a very key part for tree growth, which we'll go into a bit later. And when we look at soils, we really need to look at it from 3 perspectives. The first is biological, so any kind of life that is within the soil. And that can range entirely from any kind of small animals that are in the soil, like moles or voles, right the way through worms, through to microbes, things like bacteria, fungi, and small insects and things that use the soil. That's the first component. Then we have the chemical component, and that involves nutrients that are present in the soil. It also relates to the pH, and then the cation exchange capacity, which is basically a fancy term for how available those nutrients are, how easily they'll be accessible to roots. And that's the chemical component. And then finally, we have the physical component. So that relates to what the structure of the soil is made up of. If you think about it from the perspective of a brick and a sponge that are the same size, The brick is going to have completely different characteristics to the sponge because of its physical structure. So the brick might be heavier, denser, and it might hold less moisture, whereas the sponge will be lighter, less dense, and potentially hold a lot more moisture. And different physical characteristics of the soil will have different properties and affect the soil in different ways. So the mineral part of the soil I mentioned earlier on, it makes up around 45% of your soil. It will consist of several of three different mineral types. The first is clay. Clay is the smallest particle of the three. Clay soils tend to be quite fertile, but they also tend to be quite dense. Because it's such a small particle, there's a lot more opportunity for compaction and for the particles to become closer together and to have less pore space. Then we have the silt, which is the middle-sized particle, so it's right there in between clay and sand. And then we have sand, which is going to be the largest particle, and it's probably going to promote the greatest drainage in soils, but it won't have so much nutrient value, but it will be able to encourage more porosity in the soil that we have. And you can see from this triangle, it's not the easiest to read off of, but for example, if you had 15% clay, you had 55% sand, and then you had 30% silt, you'd be looking in that sandy loam section of that triangle. So depending on how much of each of those three different types of minerals you have will determine what kind of soil texture or type you have. And ideally, it varies between tree species, but ideally for plant growth, we want to aim in that, that rhombus, that shaded area, which tends to be the loams, so like the clay loam, the sandy clay loam. But obviously that will vary somewhat with tree species. And one of the other components of the soils we spoke about was the air and the water pore space in the soil. And it's very important for life in the soil, for biological life, depending if it is what we call an aerobic organism or living thing. So aerobic means that it requires oxygen to live. We are aerobic. Trees are aerobic. There are several different organisms in life that are aerobic. And then you have anaerobic. And anaerobic thrive in a lack of oxygen environment, and they're able to survive. So when I talk about later on an anaerobic environment, it basically means there's a lack of oxygen, probably either because there's less pore space available, or there's more water taking up that pore space and there's less space for oxygen to be in the soil. So from that image on the right-hand side, you can see that in the wet soil on the top, there's very little space for oxygen, and it's quite a saturated soil. We'll come back to that later. And in the lower image, in the dry soil, you've got a lot of pore space. You've got the same amount of pore space, but you've got a lot more oxygen, and the water is held that bit more tightly to the soil particles where it's in contact, which means it's probably going to be less available for plant roots. The other aspect of water in soil is something called repellency. So if you've ever worn a jacket or a piece of clothing where the droplets will form on the material, rather than soaking in, the droplet just stays on the surface, that is because the material is designed to be water repellent, so it physically repels the water droplet. And some soils, depending on the type, can be repellent. So that's something to consider as well when we're doing amendments or we're trying to figure out why the plants are not necessarily getting enough moisture. Is it because there's something about the soil that makes it repellent and makes that water leach through very quickly and not be retained? And finally, another important component of the air and the pore space in the soil is compaction. So when something passes over the surface of a soil, be it a human being, be it machinery or equipment or vehicles or construction related items, then you're going to be compressing and putting pressure on that soil volume. So you're going to be getting less and less pore space each time. And it only takes 4 passes of a pedestrian, of a human being, over an area of soil to compact it enough to start to see those impacts on the root not being able to get into that soil, and it impedes the root growth. So that's a very important factor of the porosity as well. So just to jump over to trees for a minute now, rather than carry on with the soils, because one of the things I wanted to indicate today is why we should be trying to improve soils for trees. Why are trees so important, especially urban trees where we as human beings quite often live. And there are many benefits of trees. There are a huge amount of environmental benefits from the perspective of habitat provision for wildlife. They reduce the temperature under the trees and of houses where the trees surround, which means that you're going to be paying less for your energy bills potentially. In the winter, it could create a more warmer environment, and in the summer, it could shade and less air conditioning, as we use over here quite a bit in the southeast of America. It can improve property value, and it can also improve human beings' well-being. There are so many positive benefits to having trees in the environment where we live. But unfortunately, annual tree mortality tends to average out around 3 to 5% per year over the first 10 years of planting. So if you imagine that, if you planted 100 trees, roughly you're going to lose 3 to 5 each year. And then over 10 years, that really does add up. It can be anywhere between, around about a third to half the trees that you plant can potentially not survive, depending on the conditions and the climate and the management. If you've got a really good management of those trees, if you're irrigating and you're providing extra nutrients, then they have a better chance of survival. But on average, globally, it tends to be quite a high mortality rate over time. And around 54% of the global population live in urban areas. So again, it's so important to maximize all these benefits that these trees can give us. And the larger the trees get and the more mature they get, the more benefits that we can achieve. And the global population that lives in urban areas is only projected to increase. I think it's 66% by 2050. So the more benefits that we can maximize from these urban trees, the better. And many of you will probably have seen trees growing in a street environment. Quite often, the soil volume that the trees are growing in is pretty limited, and it's just because of the situation where they are. They're in a pavement. They're not going to have a lot of room for their roots to grow into. So this local authority in this picture has done really well in trying to promote the health of that soil. So they've got a watering tube, that black hose there, which is going to try and channel some of that water down. And can be watered into directly by contractors as well. They've used a watering bag, which is what that green bag is around the base of the tree. So that will help to retain some of that water and filter it into the soil over time rather than just one watering event. And they've mulched it. So they really have tried to do everything they can for this tree. But ultimately, urban planted trees will tend to be in a more stressful environment than something in a more natural environment, shall we say. And even though I'm talking specifically about urban trees now planted in the street environment, everything that I'll talk about today applies to trees in gardens and public spaces and parks and all that sort of thing. So even though the most stressful environments are in the urban street tree environments, it applies to all places that trees are planted where people live. So let's go back to basics. What are the main things that plants and trees need to survive? Well, they obviously need light, they need water, they need air, and they need a growing medium. They need the soil that the roots are going to grow into. And the water and the air also apply to the soil. So one of the things we're going to talk about quite a bit today is are the roots of the tree and how that interacts with the soil and what the requirements are and how we can improve the soil for the trees. You can see from these images, I don't know if you can see my mouse pointer on the screen, probably not, but those roots that flare out from the tree trunk, those are what we would call the buttress roots, and that is the root flare or the root collar. And those large buttress roots coming out are going to be the main structural for support of the tree, the main structural roots. From those, you have some large lateral roots coming out from those large buttress. Those are also for structure, and they're also useful for carbohydrate storage and energy storage that the trees are producing. They do have some nutrient uptake value, but the main roots that take up the nutrients and the water are going to be the fine roots. And those are therefore the most important to promote in an environment where the tree is not necessarily going to be at its optimum that's really important to try and promote those fine roots as much as possible. And while we're on the slide, just to give you something to take away today, which I find is a very common misuse of trees and tree planting, is when you plant a tree, you always want to try and be able to see that root flare, that root collar where the roots are flaring out on the trunk. If you bury that area, the tissue in that trunk is not designed to be buried. It's designed to have a lot of active air exchange and oxygen access. So if you bury that at the time of planting and then the tree sinks a little over time, it's going to be a bit harder for the tree to function as it is designed. So when you buy a tree from a nursery, sometimes where the repotting occurs, soil can build up the trunk from where that natural root flare is. So when you get a tree or even a woody shrub, for example, if you just pull away the soil gently from the trunk or from the stem, careful not to disturb the tissue and the bark. But if you just pull it away until you can see that root flare, it's sometimes a little bit tricky on smaller specimens, but there will be some main roots that start to come out at one point. And if you can get down to that level and then plant that at the soil surface level, you're going to have a specimen of a tree or a shrub that's going to be a lot more likely to survive and to thrive in its environment. It's much easier to plant them higher and have that root flare than to try and unbury them over time. And if we think about where trees naturally occur in nature and in their native environment, they usually have this kind of setting. So they have, you have the tree canopy, you have understory, you have a lot of nutrient cycling in this environment. So you're going to have leaf fall in the autumn, then that's going to be broken down and decomposed in the soil, and it's going to build up the organic matter content in the soil. You're going to have branches that fall from the trees and decompose. You're going to have animal waste and animals that decompose. And all of that nutrient cycling is key to maintaining and providing that beneficial system for the roots to thrive in and to have there's nice soil structure that's required, and to have all the nutrients and the moisture that are required. And of course, it will promote things like earthworms. We all know that when we see worms in the garden, it's a good thing because it means it's a healthy soil. The worms are able to live and respire, to use oxygen, and they're able to break down things like leaves and waste, which is, as I've said, very important for providing a healthy soil. So how do urban soils vary from a healthy or a forest soil environment? Well, there's going to be a high amount of variability. Usually where there's been some construction, road building, or even in people's gardens, sometimes things that are used for the construction of the house can be dumped in the garden. One of my grandparents' houses, they'd just taken loads of cement they'd used for building and just tipped it into the soil in the garden. And everything like that will affect all those three components of the soil: the biological, the physical, and the chemical. So you've got all these less natural inputs coming from human interaction with the soil. Not only that, you're going to have potentially some pans in the soil where construction has scraped through the soil and created these pans, these layers that are not naturally occurring and could contribute to less drainage and then more saturation. And you're potentially going to have lower organic matter because, as I've mentioned before, you're not going to have that nutrient recycling that naturally occurs in a forest soil. You're not going to have that natural breakdown. We often see people going on with leaf blowers along pavements because it's for safety. We don't want to slip on the leaves. But in that way, we're just not getting that nutrient replenishment into the soil. Compaction, as I've mentioned, is a huge issue in urban areas. Every time something passes over a soil, it has the potential to compact it. It's not necessarily going to. It depends very much on the physical characteristics of the soil and the texture of the soil. But there is the potential, and the more that occurs, the less easy it is for roots to get into that soil to access the nutrients it needs. The less oxygen is available, and the more anaerobic that environment is going to be, and it's not going to be beneficial for tree roots. You're going to get greater variation in soil temperatures under things like pavement and tarmac. With tarmac, if it's that black color, it's going to absorb a lot more sunlight and potentially create greater temperatures in the summer, and then much lower temperatures in the winter. The trees are going to be less, the roots are going to be less protected. So it's really something to consider that roots are not designed to deal with these huge climatic variations in the soil temperature. So it's beneficial to try to minimize those fluctuations as much as possible. And then, as I've said, foreign materials from either construction or just from how construction can often disturb the top layer of the soil, which is what we would call the topsoil, where there's going to be a lot of organic matter. And it's going to go down into the subsoil layer. And the subsoil, even though it's still hopefully optimal for root growth, it's going to be less optimal than the topsoil. So we're going to see more of those compacted soils and less nutrient potential, potentially, depending on the soil. And also pollutants. So things like from exhaust, from vehicle exhaust, some oils, and then some de-icing salts. I'll go into that a little bit more later when I talk about nutrients, but there's all these foreign materials or foreign inputs, pollutants and things that can affect the soil. As I've said, less nutrient input from the leaves. So one of the major factors of soil that's really important for plants, as you may imagine, is the moisture. Water and moisture is so important for plant growth. It affects how they can take up nutrients from the soil. It affects their structure. So when you have water in those plant cells, they're more turgid, they're more structural, helps the plant to not wilt. It's used in photosynthesis, and it's used right the way from germination. So right from when that seed first germinates, water is absolutely essential for life. The amount of water that's needed depends on the species of plant or tree that you're planting. It does vary greatly. It's always helpful to look at what that tree's native environment was, where it first came from. So for example, some types of Taxodium disticum, which is a type of cypress, is more preferable to a saturated river or swamp type environment. Whereas you might get something that was originally from a desert and is more adapted and tolerant of drought conditions. So you wouldn't then want to irrigate it constantly because it may not respond well to that. In soils, we typically want to aim in between field capacity and wilting point to get that optimal moisture range. Now, field capacity is the ideal amount of water in soil. So it's when the water is most available for plants and for roots. And then wilting point, as it quite says in the name, it's the point at which a plant wilts. So it's the point at which the roots can no longer access the water, especially enough water to support its above soil canopy. And saturation, just to quickly mention that since it's on the slide, is where you're at absolute full capacity of water in the soil. There's no air space, it's just completely full of water. And this is not entirely unusual after a large rain event, especially, as I've said, over here in the southeast, we have a lot of hot, humid weather. And when we have a torrential downpour, there's so much water in the soil, it's really at saturation point. But as long as there's the drainage to maintain that over time and it will make its way through the soil profile, it's not as detrimental. pH is something that we probably all come across in science lessons. It's a measure of how acid or alkaline a solution or a media is. In this case of soils, it can dramatically affect how available nutrients are for root uptake. It doesn't tend to vary too much within a single garden. It can do depending on what kind of inputs there have been to the soil, but you tend to see greater variation across large parks or even across counties and that kind of scale. But it is worth considering, especially if you had a particularly acid loving plant like an azalea or a rhododendron, or a particularly alkaline loving plant. Soils tend to range between 3 and 10 on the pH scale. The ideal soil would be around 6 to 7.5, but again, it varies very much on tree species, and I'll show you a few of those values in just a second. Here is a really good visual diagram of why different pHs are important for different nutrients. So you can see where that green bar is on the image. That range there between 6 to 7.5, somewhere in that range, is where nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium are going to be at their most available. That's what that green color on those horizontal bars indicates, when they're at their most available. And there are some nutrients, as you can see, that are more available at a more acidic range, but it depends on the plant species as to what their requirements are. And there are resources available. We have one as a company that's available to the public, and I can give Catherine the details of that to post with this after the webinar. But it's very important to understand that interaction between pH range and nutrient availability. And here, I won't go into this too deep, but here you can see there is a huge amount of variation in what the optimum pH range is per species. A lot of these are American species because Bartlett is originally an American company, and this was designed as a resource for the American offices, but there's still quite a few species and genuses that apply to the UK. So you can see ash, for example, has a very large optimum pH range. It can deal with pHs anything from 5 through 8. Whereas something like a holly or a hawthorn, hawthorn can only deal with 5.5 to 6.5 as the optimal pH range. So outside of those pHs, you may start to see some deficiency symptoms or some damage depending on how available nutrients are, etc. So we've spoken a lot about nutrients already. Many people may recognize the NPK from fertilizers. It's a very common term used in gardening and in the industry. So the NPK stands for 3 macronutrients, so the larger nutrients needed by plants. And those are nitrogen for the N, phosphorus for the P, and potassium for the K. And I'll go into interactions between those in just a second, but those are the major nutrients that we think of when we think of plant growth. Then we have micronutrients, which are equally just as important and quite often assist in the use of the macronutrients. And then we have salts. And quite often salts get quite a bad name with plants. We think, oh, salt damage, salt toxicity, you know, salts are not good for plants. And table salt, as in sodium chloride, is not beneficial for tree growth. It's not going to have a positive effect on our trees. And that's quite often what's used in de-icing salts. Now, I'm definitely not recommending not using de-icing salts. De-icing salts are very valid and should be used. But if you've got a tree that's located near somewhere that may have those salts applied, it may be worth considering if you see burning around the edges of the leaves, that it could be salt damage. However, like I said, please do use de-icing salts. They're very important for use in our urban environments. But it's just something to be mindful of. But there are a lot of beneficial salts too. So things like ammonium nitrate is very beneficial for plants. It is how nitrogen is taken up by the plant. So a lot of these nutrients are not taken up in their elemental form as nitrogen. For example, nitrogen is taken up as nitrate, NO3. So you have that oxygen component in there. So it's not as cut and dry as it seems. There's a lot of interactions, but sodium chloride and the chloride salts in general can be more detrimental to plant growth because it's the chlorine and the chloride that's taken up into the plant and causes that peripheral burning on the leaves. So here's just, I won't dwell on this slide too much, but here's an introduction to how those different nutrients are used in the plant and what their functions are. And you can see there's a huge amount of interaction between some of these. So for example, nitrogen is a huge component of chlorophyll, which is the green pigment that's in leaves that's used to absorb light to use photosynthesis. And iron is also used for some of those pigments, so there's an interaction there. With potassium, it's vital for the movement of water and nutrients into the plant. And then phosphorus, you've got an interaction with magnesium. Magnesium is essential for carrying and using phosphorus, and phosphorus is used in energy that's produced by plants. So without all of these different components and these different nutrients working together, you may see some deficiency symptoms, which basically means that they're not getting enough of what they need. And the images on this slide indicate some of those deficiency symptoms. So you may see some yellowing. Phosphorus deficiency sometimes has that black or purple color, peripheral burning or discoloration in between the leaf veins. If you see discoloration in between the leaf veins, it can indicate a nutrient deficiency. It doesn't always, and it's very important to test for that in the soil or the leaves to make sure it is that that's causing it. Sometimes if the plant is displaying symptoms of nutrient deficiency, it's not that the nutrient isn't in the soil, it's that the plant can't access it. So perhaps there's a root disease in the root system, which is stopping the proper uptake of the nutrient. Or maybe, as I've said, there's a nutrient that interacts with that particular nutrient that's missing. Maybe there's a huge amount of that macronutrient present, but we haven't got the micronutrient. So it's very important to test and see what the analysis says about those interactions in the soil. It's not as simple as just applying an NPK, although in some cases that is beneficial. And of course, if we have a healthy soil, we're going to have a lot of life in the soil. We're going to have some animals, some microbes, some insects, and some of these organisms, these living things, are beneficial for tree roots. So some things like the two images at the bottom of the screen that they're taken out of a microscope. The one on the left is called trichoderma, and it's a beneficial fungi. And the one on the right is a bacteria, Bacillus subtilis. And these are both certain types of these are both symbiotic. They work with the plant. So the plant provides them some kind of nutrient or some kind of benefit, and they provide other benefits to the tree. So they work really well together, and they buffer when there's some kind of, dramatic drought event, or there's something climatic that changes in the soil. They can help each other to buffer through that hard time. So it's really important to promote those kinds of healthy soil life. And one thing that completely blew my mind when I first heard it was that in a mug full of soil, so if you can visualize that in front of you, in one mugful of a healthy, ideal soil, there are more living organisms than there are human beings on the planet. Now, the current global population, I think, is around 7.8 billion. So if you can think about one mugful of a really healthy soil has almost 8 billion organisms in there, and each of those plays its own role. Some of them are bad, some of them are negative to tree growth. They could be disease, they could be pathogen, but a lot of them are going to be very important to the balance of a healthy soil. So how should we assess our soil to see if it is ideal for tree growth? Well, as I've mentioned, there is the topsoil layer, and then there is a subsoil layer, and it's very important to sample from both. Tree roots don't always grow as deep as people think. It depends on species. Some do have the tap roots and the deep roots. But on the whole, a lot of the roots are going to be surface within the top, 50 centimeters of soil to 60 centimeters of soil. They're mostly going to be in that range. And so we really want to be able to sample from all of that region of soil to see what's available for those plant roots. One thing you can do is you can dig down yourself with a trowel, or preferably with a cylindrical corer, because that helps to take a nice profile of the soil. If you're looking for nutrient analyses, I would recommend going through a laboratory rather than using at-home testing kits, just for accuracy. We as a company do that for our clients. We will test soils for people, and then we will report those soil results in relation to the tree species that they are selecting to plant or that's already there. So we can really tailor what's there to what is necessary for that species. So I would recommend a laboratory test for nutrients. But from a perspective of pH, again, laboratory can test for that. But you can use at-home testing kits. They won't be as accurate, but with things like pH, the margin for error is less. So I would say that, you're more likely to get a good assessment for that at home. You can use litmus paper. You may have come across that in science class at some point. You can use litmus paper, and it will give you a color indicator of what the pH is of that soil. You can also visually look at the soil. You could either take cores, as I've said, and maybe lie them out on a tarpaulin or some plastic of the profile, or you could dig a hole or a pit. That can be a bit more labor intensive, so it depends how much you're committed to doing that. One of the things to look for is this graying, or what we might call glaying in the soil, and that is an indicator of an anaerobic environment, so an environment that's low on oxygen. You can see in both of those images there's some graying in those, and this is another example of that graying here. So the left-hand soil is a relatively healthy soil. It's looking pretty healthy. There's a nice top soil layer of brown soil that's got rich in organic matter, it looks like. And then you have your red subsoil. That to me looks like clay. Red, if it's red, it could be a clay. It's an indicator, especially over here in the southeast. We have a very red clay that stains your fingers. And on the right hand side, you can see that grey and that glaying again. And you'll notice at the bottom of that image, there's some streaks of orange and some pockets of orange. Now that's different from the one on the left where it's a consistently red soil. Those pockets are quite literally iron rusting in the soil. So that is indicating that there's a very high presence of moisture, as with the grey glaying. It's too much moisture for aerobic conditions in there for a good biological life in that soil. So you would want to try and improve the drainage in that kind of soil. And probably the organic matter content too. That's probably a clay soil looking at it. And the other things that you can do, you can, I won't go into it too much now because it's much easier to see than for me to describe, but you can do a drainage test if you think you have a drainage issue. If you Google percolation test, like drainage percolation test, it essentially consists of you taking a core out of the soil or digging a hole and then filling it with water, filling it again and timing it and seeing how fast it drains. And then there's some different thresholds of timings that will give you an indicator of how well your soil drains. But I would recommend, there's some YouTube videos out there that are really great. I'd recommend Googling that. And the other thing you can do is if you take a sample of that soil in your hand and you very slightly wet it so it becomes like a paste, and then you can quite literally roll that in your hand. And again, you can Google, this one is called soil texture feel test. And there's flow charts, there's videos that talk you through how to feel that soil and the texture of the soil. And you can roughly estimate how much sand and how much clay and how much silt and what kind of texture of soil you've got in there. So if you look up those resources online, there's plenty out there. I can share some links to ones that I use. One key indicator for that is if you roll it in your hand and it stays in a ball or in a sausage, but if it stays in the shape, it's more likely to be more of a clay soil. If it feels very gritty, it's more likely to be a sand soil. But there's a nice flow chart that goes to different things like sandy loams, sandy clays, clay loam. There's so much diversity, so it's worth following that step by step. So how would you want to alter your soil? Well, as I've said, I cannot emphasize enough the importance of assessing the soil first. If you don't know exactly what issues you're facing in your soil or what deficiencies there are, it's very hard to select the right amendments and the right applications and the right things to do to your soil. So please definitely assess it first, either with the laboratory's help or visually yourself or online resources. Definitely do some kind of investigation first. And then think about the 3 different components of soil, so your physical, your chemical, and your biological. What is it about those 3 that you want to improve? What are your functions of the soil? What is the outcome that you are desiring? And then you can decide what you want to do to the soil, if anything, and what products and amendments you want to add. The number one thing that if you can take away from today, I would recommend is mulch. Mulch is absolutely brilliant for any kind of plants, especially trees. It can be any kind of surface covering, but I personally recommend something of a natural origin, so some kind of biomass, either bark chips or composted matter, leaf litter. There's been some debate in recent years over, say you had a wood chip that you just had a tree taken down, it went through a chipper, and you have this chip that comes out the other side. There's been some debate as to whether or not fresh chip and compost chip, which one's better and which one would be better for use on trees. There's no real difference other than the composted chip will be closer to releasing those nutrients and giving those to the tree, whereas the fresh chip will take more time to compost. But if you're going to be composting them anyway, you may as well put them on the surface of the soil and let them compost naturally. But any kind of natural product like the leaf litter I've just mentioned, Make sure that it's not dyed. There's quite a few, especially the chunkier bark mulches that have been dyed. And sometimes they use naturally derived dyes, sometimes they don't, and that can be a potential to introduce pollutants to the soil. So I would just say go as natural as you can, some kind of mulch to put on that surface. You ideally want to put down 5 to 10 centimeters, which is quite a deep amount. It's quite a large amount of mulch, but in that way, you're going to get the maximum amount of the benefits, which I'll discuss in a minute, and you're not going to have to reapply so often. So you can probably get away with applying every 2 or 3 years rather than every year. At the Arboretum here where I work, we apply every year, but the climate is so warm here and so hot, we need to get the full maximum benefits that we want out of that mulch. And because it breaks down so quickly because of that heat, the microbes are so much more active. And ideally you want to apply that mulch to the drip line, which is basically where the edge of the tree canopy reaches to, where that last branch and last leaf, reaches to. The more area you can give that's mulch, the better. Unfortunately, in some situations, for some gardens, there's a lot of lawn. You may not want to dig into the lawn too much, but as much area that you can give that's mulch, the better. And we would call that a mulch ring or mulching to the drip line. Here's some of the benefits, excuse me, benefits of mulch. It's a direct supply of organic matter, so it's going to improve that soil structure, knowing it's going to reduce compaction. It has potential to moderate soil temperature and promote biological life. It conserves soil moisture. You don't get so much evaporation from the soil surface. It will prevent erosion. It will eliminate competition with the turf that was originally on top, because there's a lot of competition with those roots for resources. It can suppress weeds. You'll spend so much less time weeding your garden if you have that nice thick layer of mulch, because the weeds just don't tend to be able to grow through as easily. You might still get a couple of thugs coming through that are a bit more hardy, but you're going to get far less germination through light suppression, and you're going to get less actually being able to grow through. And of course, mower damage, because if you're mowing right up to the tree trunk, you're more likely to see damage from the mower and from the strimmer. Whereas if you've got that nice mulch ring, you just have to mow around the mulch. It's a much easier process. You may want to reduce compaction. You can manually cultivate the soil yourself. You can dig it over with a fork, or as a company, we use something called an air spade, which sends pressurized compressed air through the tool into the soil and breaks up those aggregates and breaks up the layers and provides more pore space. You can also incorporate compost. Compost is one of the best amendments that I would recommend. It's pretty much universally useful and beneficial depending on what, no matter what soil you have. Putting more organic matter back into that soil is always going to be beneficial. And then you can put in other amendments. So things like biochar, which I'll mention in a second, can help to improve the structure of the soil and improve the porosity. So which products? Sometimes it can be a little confusing in the garden centres. There's so many products available. Things like perlite on the left there, vermiculite on the top right, they tend to be better for potted plants and smaller herbaceous plants. They're ideal for, well, the vermiculite is ideal for seedling germination, for getting that light texture of the soil. But for trees, we're not going to be seeing such great benefits for those. And I'll talk more about biochar and why that's beneficial in a second. Wood ash on the bottom right is going to be more of a fertilizer input than anything else, and it's certainly not going to be detrimental. So if you've burnt some wood and you get that wood ash after, it's absolutely fine to incorporate that into the soil for some more nutrient value. I would just say caution on that if you have wood that's been treated to last. So if it has tar or turpentine or other additives that have been added to it to make it last and not weather and degrade, because then those will be transferred into the wood ash potentially and then could affect the root growth in turn. Then there's a lot of these different products like compost teas, hormones, superfoods, the humic acid. In my personal experience, I haven't found a product that can actually provide more benefits than compost can. But I wouldn't say that, there's negative impacts. I just, in my personal professional experience, I haven't come across a product yet that can do, can benefit everything as much as compost or some other kind of natural amendment. Of course, it's not probably going to have a negative effect, and it is going to have some kind of fertilizer effect too, but it just may not be worth the financial investment for the benefit that you're going to get. And the last amendment I wanted to talk about really quickly was biochar. So this is something that I'm currently researching for my PhD. Biochar, if you think about it, it's like a charcoal, but it's a very specific charcoal. It's not like the charcoal you're going to get at a B&Q or a shop like that. It's a lot more specific conditions that it's produced in. It's produced from any kind of biomass. My preference is wood-based biochar. But if you think about it like a sponge, it's going to help to maintain the moisture and the nutrient availability in soils. It's going to improve aeration. It's going to improve soil structure. The effect varies with soil type, and obviously if you have a very healthy soil that's already rich in organic matter, you're not probably going to see the benefits that you would see if you have a particularly waterlogged clay soil or a particularly high draining sandy soil where you need that retention. So it's definitely worth considering, but for sure, make sure that it's right for your situation and that it's not just going to be, an additive that isn't necessary. Again, won't do anything negative, but not necessarily worth the investment. Irrigation is very important. My preference is the bottom left with the soaker hose because you're going to get less chance of it spraying off in a direction where it's not needed. It's a very direct input into the soil. So if you've got a tree species that you know is very water demanding, you could put irrigation in to assist with that. But it's very important to make sure you get the balance right and not to then overflood the tree. It's a very fine balance, and it's worth buying a soil moisture probe or assessing the soil somehow to see how the moisture level is in that soil. And on the other end of the scale with draining and aeration, things like lawn companies use aerators where you just punch holes essentially into the soil, and that will improve the aeration. You can trench and put in some plastic materials that will help with drainage. It will create a pocket where the water can drain into. But essentially, it depends on the soil type, whether you need to add some organic matter to it, whether you need to add some kind of sand or gravel or drainage material, or biochar. Biochar can also help improve that porosity and improve that drainage. Or manually cultivating the soil can sometimes also help to loosen the soil and improve drainage and aeration. So it entirely depends on the texture that you're dealing with. And finally, reducing soil pollutants and salinity. It's a very hard thing to do, but if you know you've got a problem with salinity and salts in the soil, you can drench the area with water temporarily to help to move that soil through. If you're already seeing the salt damage in the leaves, it's probably a little late to do that, but then next time you know there's going to be some salt applied nearby, you may want to consider doing that to improve the situation for the next time. And there's certain plants that you can use that will accumulate things like heavy metals and pollutants in their plant tissue. And it doesn't necessarily damage that plant, but they will take them up from the soil. Things like sunflowers can be quite helpful for heavy metal accumulation, as we call it. And again, biochar has been shown in many scientific studies to be able to remove contaminants, locking it to the biochar surface to remove its availability from plant roots. And one thing I should say with biochar as well, actually, is that we recommend as a company applying biochar with compost and plenty of water and potentially fertilizer if you're going to apply a fertilizer, and depending on what the nutrient requirement is of the soil, because sometimes that sponge-like nature of the biochar can hold on to those nutrients and water a little too tightly. So if you apply it with plenty of compost and water, then it's not going to instantly bind up anything. It's just going to be a nice buffer for the soil. So some quick takeaways: make sure you think about and analyze those three components: the biological, physical, and chemical. Compost is often very ideal for soil improvement. I would recommend that first in mulching, but it depends very much on what your conditions are in your situation. Removing grass beneath the tree can only reduce the competition for resources in the soil. Enriching your soil with correct amendments to your situation, as I've said, with that assessment, make sure you're targeting whatever function is your desire. And then good soil is a very fine balance. You want to make sure you can get a balance between those three components. It's not always easy. And for that reason, I would always recommend selecting the right plant for the right place rather than trying to amend the soil for a plant. that you would like to plant. It's difficult sometimes when we really want to plant something in our garden that we like say the rhododendron, and we've got an alkaline soil. You might want to amend it with some more acid amendments. And sometimes with ericaceous plants that can be achieved if you've already got a neutral type soil. But on the whole, I would recommend selecting the plant for the place as a constructive way forward. So that concludes my presentation. I'll stop sharing my screen and pass over to Catherine for questions.
Unmute, there we go. Thanks so much, Emma. I've really learned a lot in that presentation. It was fully comprehensive and it's expressing the importance of soils. One thing that's particularly interesting to me is about the red streaks and the glaying, because we have a lot of clay soils in Sheffield, and we have an issue with that often when we dig down. You find those red streaks around because obviously there's a lot of iron in the soil, being a steel city. But I never realised that that was an indicator of waterlogging. That could be that's what I said. That was very interesting.
Excellent.
We've got some questions here. We've got a question from Colin McCulloch, who asks. He says, "I'm interested in the restoration of degraded lands due to deforestation, especially on the slopes, hills and mountainsides, then causing erosion of topsoil, water runoff and flooding downstream. Can you comment on the use of trees in stabilising such hillside situations? Is it better to plant a lot of very small trees, saplings, or larger mature trees, wider spaced? Will trees benefit from geotextiles or other mechanical stabilisation? And how would you manage that as the trees grow and the roots extend?" So there's quite a lot of questions in that.
Yes, that's a really good, important topic though. I've not done a lot of research into that myself, but I have read some research into restoration of especially old mine soils and things like that. It depends entirely on the slope of the land and whether or not it's that you want to correct the soil from any contaminants that are there. In terms of whether it's better to plant smaller trees or larger trees, I would say smaller trees to begin with, and then potentially coppicing or harvesting some of those trees, because when the trees are starting to establish, it can sometimes help to be for there to be numerous trees to help with support and then like wind exposure and things like that. But obviously as the trees grow, you probably want to remove some to help those existing maturer trees to flourish. Another really important factor with that would be to try to ameliorate and amend the soil as well prior to planting. The number one thing I would recommend is some kind of organic matter input, be it biochar, be it compost, or some other kind of input. That would be one of the key things to do there. I can't comment on specific tree species that I would recommend, as I'm not too familiar with that. I can certainly send out some information if that's of interest, of some papers I've read, but other than that, I hope that's helpful. If you have any other specific questions around that I've missed, please feel free to post.
Okay, thanks, Emma. I hope that answers your question, Colin. There's another question here from Julie. She asks, where should you take a pH sample from? Topsoil, subsoil, or both? Each layer in an auger sample.
Okay, great question. Yeah, so I would personally say if you were going to be restricted or time restricted to doing just one or the other, I would say the subsoil, or you could mix both. Ideally, you want to be able to take a sample from both. And on that subject as well, if you've got a tree and you're looking at a whole area around a tree, you want to take multiple samples from in that area. We tend to think of it like the number 5 on a dice, where you get those 5 spaced out dots. You kind of want to look over that per probably 1 dot per meter squared, I would say, depending, one sample on each corner of a meter squared would be ideal for taking samples. And yeah, trying to take a sample separately from the topsoil and the subsoil so that you can see exactly what's going on with each, because they will vary quite dramatically. And I'm trying to think from an auger. So if you mean sort of like a Dutch auger or some kind of core removal, you could take 1 core sample from the topsoil and then 1 core sample from the subsoil using an auger. I hope that answers your question.
Okay, that's great. Thanks, Emma. So thanks, Julie, for asking the question. I've got a question, Emma, because a lot of the planting that we're doing in community forestry in Sheffield is around whip planting. And it's been very helpful. We've had quite a few volunteers helping us mulch the plants. And actually, the mulch was donated by some of our tree surgery companies. So it was all very much, it's all, everything was given. So that was fantastic.
Excellent.
With a small whip, a whip that's about 40 to 60 centimetres high, how much mulch is the right amount of mulch? Because obviously 5 to 10 centimetres would be a lot, wouldn't it? So is there a recommended depth for whips?
That's a really great question. Yeah. So, I mean, I would probably still aim for 5 centimeters, but you've raised a really good point there, in that when you're mulching any kind of woody plant or tree, you should always try and do it in a donut kind of shape. So you leave a small space in between that root flare and where the mulch starts, just for that same reason of not burying the root collar and reducing the oxygen to that area. I guess with that kind of size tree whip, I mean, any is better than no mulch at all. Any kind of covering is going to dramatically change the effect on the soil. It's very complicated for me now because I've started to work in inches rather than centimeters too. But I would say, I probably would say around 5 centimeters would be the ideal depth, but then bring that in at the base of the tree. But as much as you can do is going to be beneficial.
I think donut is a good guide, because a lot of our mulches are about 7 years old. So, but a donut is a good description.
Excellent.
Excellent. Well, thanks so much for talking to us today, Emma. It's been really great to have you on, and there's so much information there, and as a resource to keep all that information around soils affects all of us that are planting trees, or even people that are planting in their own garden. And just bearing in mind that the importance of soils and how it really does make a difference to the way that your plants and trees grow. So thanks very much. And yes, so that's the end of our webinars for today. If you'd like to join some of the other webinars, we've got Trees in Art and Design tomorrow. Then we've got Paul Wood talking about London trees. He writes about urban trees in London on Friday morning. And then we have the street tree consultation and a panel talking about that on Friday afternoon. So if you can, then please join us for those. But otherwise, thanks for joining us today. And thank you again to Emma. We'll see you again soon.
Thank you very much.
Thank you.
Thanks.